Hello everyone. Today I want to show you a little script I made to help me generate DXF files from VSP models. So yeah, basically what you need to do is let's go to you basically would go to your VSP models. For example, I generated. Well, I didn't generate it. I downloaded this Cessna 172 model from the VSP hangar, and I have isolated the fuselage because this is mostly meant for the fuselage cross sections. The wings cross sections, you do know what they are. They are the airfoils that you downloaded or that you generated with an equation or I don't know, a CAD file. So those are known. The problem we have, or I had, was that I would design my fuselages in OpenVSP because, well, VSP allows for a lot of pretty interesting fuselage settings and controls and different cross sections and whatsoever. So I would use these to create my fuselage, but then if I wanted to do something other than 3D printing, for example, to cut it out of foam with a hot wire cutter, either a manual one or a CNC one, then I would need these cross sections to do the linear interpolations between them. So what I did was, again, I isolated the fuselage because this script is only works with a single component. That's a pretty important limitation to keep in mind. You would go to Analysis, Planar Slice, and then you would give a VSP the number of slices you want and the normal axis you want to select. Now it's important to note that, well, you can give, for example, 15 to say a number, and this auto feature starts at the beginning of the fuselage and ends at the end. The problem with this is that when you use it, you lose the first and last slice. So yeah, keep that in mind. If you don't want to, you can just we can actually move this here to the 0 point so that it's easier. Refresh this. So maybe we can start 10 centimeters ahead and we can end also 10 centimeters before. And we are going to do 15 slices and we slice it. And then we have this mesh geometry. We can turn off the mesh and we have the slices. If we shade them, we can see them. Here they are. So to export these slices, I would go then to here to the export tab and select .tri, and then actually let's not get confused. Yeah, it's empty. I would go then to this meshes folder and say Cessna 172 along the X direction and accept. And then you would get this, well, you actually get two files, but the one that has the information we want is this try file that has the number of points and the number of connections. But we're only interested in the first part, that's the number of points. These are the connections. Anyhow, so you would go to the script and give the file name here. So it's 172 X direction and name the normal axis. In this case, it's the X axis and simply execute it. Now the script will take the points and order them using their polar coordinates, also the angle they have with respect to the origin, as well as the distance as a second sorting criterion. And then it will, order them so that you get these cross sections properly, like the outline, instead of just the whole disaster that is uh, to the actual triangular mesh, because if you don't do this sorting, you get all these random lines instead of the triangular mesh. Actually, I can show you. If you don't do the sorting, we can plot the cross sections instead. Oh, it's centered as well, but so they are around zero. So if we don't sort them, we get these lines, but this is not really useful for a AutoCAD software to like to for an DXF file because well we're not getting the outline. So yeah, that's why it's necessary to sort the points and before you can plot them. Now I plot them here using Matplotlib just to help visualize each of the cross sections, but the exporting is actually happening here. And as you can see, I've gotten the 15 DXF files. And right now we could go to the folder and see them. Now it's important to know that here you see like this little blank space. That's because the first point does not connect to the last point in Matplotlib, but using this line, I do create a closed curve in the DXF file. For example, the X section 4 here, if we open that and go see this area, you appreciate, and it's kind of dim, but you can see it's a closed curve. So yeah, basically it. I have implemented it so that you can change the angle as well. So for example, if you wanted to instead slice along the y-axis, you would get in these cross sections. We hide the mesh. You can see look like this. And then you would export them. Now let's call this y direction. Y direction. And also change this. And now we would get all the cross sections. These are for the problem of the model, and it depends on how well your model is. But as you can see, most of them give okay results, good results actually. Yeah, basically, actually I'm getting more than the 15 cross sections, and that's due to the fact that I'm also getting these weird lines, and that has to do with how the algorithm processes the cross sections. In a nutshell, we basically look for unique, in this case, y values, and all the points that have the same y value are interpreted as a cross section. And so yeah, probably we have these weird lines at some point, and that's why the solver, the algorithm has interprets them as cross sections, but they really aren't. So you just would need to purge them, uh, so you could actually get your actual cross sections. Again, that problem I will lead in with this models in the y direction. So yeah, we can try a different model. For example, it's F16. As I said, this works only with one component. We can actually, for example, let's. This is the fuselage, canopy, and an inlet. Maybe we can hide the inlet and do the fuselage and the canopy. You would say, okay, this looks fairly simple. The program should be able to do it. The fact of the matter is that it's not able to do it. Let's increase these to 20 maybe and slice it. And maybe these seem to be okay, but let's export them to do the test. X16 canopy. And then let's also do also one without the canopy. So just this, slice it, and export it as a TRI file, X16 without canopy. Okay, so now we can go here, X, and if we do the canopy one first, everything canopy, you'll see that the results are not good. That's because I'm not actually verifying which points are part of the outline. I'm just sorting them using like the angle they make in a clockwise manner or counterclockwise. I'm not sure, but yeah, that so if you would go here and show the mesh with the canopy and convert to a point cloud, you would see that the points that are included in the TRI file are also correspond to the outlines of both components. That means the outline of the fuselage component, but also the outline of the canopy component. So these points in the inside are also 1, 2, 3, 4. For example, let's see, 1, 2, 3, 4. These points on the inside are also taken into account, and that's why we get these weird shapes, because they also get connected instead of going around the outline. Uh, Maybe in the future, when I have more time, I can try to implement it in such a way that we can work with such compound or combined shapes. Right now, to be perfectly honest with you, the things I need to do not really involve combining uh, two bodies, so I'm not really, it's not a priority right now, but maybe in the future it'll be. If we just use the fuselage, you can see that although these cross sections are not particular, are not simple shapes, there are no circles or simple rounded rectangles. You can see that you can get them you can represent them pretty well. Let's leave that and let's show this only. Now, as you can see, how sharp your corners are depends obviously on your tessellation. So if we would go here and increase this, we could get a better geometry or a smoother geometry. So we can do this, hide the mesh, export it, and we can save it. And as you'll see, now the curves are way smoother. So yeah, basically that's it. Again, remember, do not do two shapes at a time. You can do one shape at a time only. You can use the X or the Y axis. I haven't tested the Z axis, but I don't think anyone would do that with the Z axis. And yeah, I guess that's it. Yeah. So yeah, thank you for watching. If you have any questions, you can always ask them in the comment section. And this will be available in my GitHub repository, as a GitHub repository in my GitHub. The link I will leave in the description. So yeah, goodbye.